students, welcome to Gurudeva online classes. Dear students, in previous class we had completed coal and petroleum chapter. Now I am going to start a new lesson, that is force and pressure. Dear students, you have studied about motion in 7th standard. Here we have to know here how moving objects from one place to another place. Dear students, do you recall how we can decide whether an object is moving faster than other object? What does the distance moved by an object in unit time indicate? Dear students, when a batsman hitting a ball, that ball moving from one place to another place, how we can decide whether an object is moving faster than other? Also, you know that moving objects like a ball rolling on the ground and slows down, it maybe changes its direction of motion, or it maybe changes in the speed also when a ball moving from one place to another place. It is also possible that the ball may slows down and also changes its direction of motion. Dear students, let us recall some of our everyday experiences. See, what do you do to make a football move from one place to another place? Dear students, what do you do to make a moving ball move faster from one place to another place? Dear students, how does a goalkeeper stops a ball? And when we playing a cricket match, do you know how do fielders stop a ball hit by a batsman? And a hockey player changes the direction of the moving ball with a flick of the stick. This is how possible to hockey player to changing the direction of the ball when flicking the stick. In these all situations, the ball may be moving faster, the ball may be stopped to move, and the ball may be changes the direction of the motion when the ball moving from one place to another place, the ball changes the direction of motion. Dear students, as I said, a force has been applied on the ball. When we applying a force on a ball, that is changing the direction of the motion, and that is stop to move, or that ball moving very fastly when we applying the force on that ball. Dear students, when it is kicked, when it is pushed by hand, dear students, this ball moving faster from one place to another place. Dear students, but we have to understand here what is force. What happens when we applying force on an object? When we applying the force on a ball, what happens? We have to understand here what is mean by force. What happens when we applying force an object? Dear students, when we applying force an object that is moving very faster, or that is stop to move, or that is changing the direction of the motion when we applying force on an object. Dear students, we shall seek answers to such type of questions in this chapter. Dear student, first point I am taking here, force. Force, a push or a pull. See, when we pushing an object, or when we pulling an object, we applying force on that object, then only that object moving faster, or that is stop to move, or that is slows down, When we apply force on that object, that is slows down, and when we apply force, that is that object will change the direction of the motion. Dear students, we are using so many actions like picking, opening, shutting, kicking and eating, lifting, flicking, pushing and pulling. These all actions we are using to describe certain tasks. When using these actions usually result in the same kind of the changes in the motion of an object. Dear student, let us see here. I am showing here one table. You observe here all these actions are showing to us same kind of the changes when we apply on an object. Let us see this table.
Dear students, in this table given here some situations and some actions also given in this table. See, these all situations: moving a book placed on a table, opening or shutting a door, drawing a bucket of water from a well, and a football player taking a penalty kick, a cricket ball hit by a batsman, moving a loaded cart, and last one, opening a drawer. Dear students, in these all situations, actions can be grouped as a push or a pull. Dear students, you observe this complete table.
Dear students, you have seen so many situations. Do you notice that each of the actions can be grouped as a pull or a push to move an object from one place to another place? Dear students, it has to be pushed or it has to be pulled. Dear students, in science, a pushing or a pulling an object, it is said to be force. When we pushing an object, we applying force on that object. When we pulling an object, we are applying force on that object. When we applying force in that object, that is moving from one place to another place. And when we applying force on that object, that is changing the direction of the motion from one direction to another direction. When we apply force on that object, that is stop to move from one place to another place. Dear students, we have to know here pulling and pushing of an object, that is we will call force. Dear student, push means force which tends to move the object away from the direction of the force applied is called push. And pulling means force which tends to move the object towards from the direction of the force applied on object, it is we will call pulling. Dear students, we know force is measurable quantity. Force is a measurable quantity. The strength of the force is expressed by its magnitude, which consists of a numerical value and a unit. The SI unit of the force is newtons. Dear students, it can be measured with a device called spring balance. Dear students, it can be measured with a device called spring balance. Dear student, spring balance, it has a spiral spring with a pointer attached to it. When a force is applied, the spring gets stretched. The results in the movement of the pointer on a graduated scale. The reading shows by the pointer gives a measure of the force acting on the object. Dear students, we are using to measure the force, that is we will call spring balance.
Hello, my name is Professor Mac. Welcome to my laboratory. Come and have a look at this. This is a Newton spring balance, and it's a device which enables us to measure force. It has a fixed end, which is used to support the balance, and a free end, which moves. So how does a spring balance measure force? Well, as my hand pulls the free end, it stretches a spring, and in doing so, I can feel the spring applying a restoring force to my hand. In order to maintain the stretch of the spring, I have to apply a force equal and in the opposite direction to the restoring force generated by the spring. As I increase the stretch of the spring, I have to apply a larger force, and as I do so, the spring applies an equal but opposite larger balancing force to my hand. So in a spring balance, there is a relationship between spring extension and applied force, and therefore by measuring spring extension, we can measure applied force. In order to do this, we have to know the precise relationship between spring extension and applied force, and to establish this relationship, we need to conduct an experiment. So as part of our experiment, we need to measure spring extension. You can see on the spring balance we have a scale, which measures the extension of the spring in millimetres. We see that we have zero extension of the spring, as shown on the scale, when zero force is applied to the end of the spring balance.
Dear student, this is one of the devices we are using to measure force. This is we call spring balance. Dear student, next point I am taking here, force are due to an interaction. Force are due to an interaction. Dear student, at least two objects must be interact for a force to come to play. Thus, an interaction of an object with another object results in a force between the two objects. We need two objects to getting the force. When two objects are interacting to each other, there is we getting the force. Dear student, for example, a man standing behind the stationary car, he will not pushing that car. Is it possible to move that car from one place to another place? That is not possible. If a man standing behind the car, that is not moving. If a man standing beside the car, that car not moving. When a man pushing the car, that is moving from one place to another place, because here two objects are interacting to each other. When two objects are interacting to each other, then only its force is produced. Okay, dear student, you notice this point, when a man pushing, a man has to be pushed the car to make it movement. If a man not pushing the car, that is not moving from one place to another place, and that car will not changing any direction if the man not pushing the car. When a man pushing the car, then only that is moving from one place to another place, and that is changing the direction of the motion when man pushing the car. Because here two objects are interacting to each other, there is getting the force. Dear friend, now I am showing here some picture. You observe who are pushing to whom, who are pulling to whom. Let us see first picture. Dear student, in this picture, here two girls are playing to each other. Here we have to observe here two girls also pushing to each other. Let us see another one picture here. Here also two girls are playing. But we have to know here who pushing to whom. Dear students, you observe this picture. Two girls also pulling to each other here. And let us see next picture. Here cow, that is pulling to man, and man pulling to cow. Here two objects or interaction to each other to produce the force, to apply the force. Okay dear students, next point I am taking here, exploring forces. Dear students, let us try to learn more about forces. Dear students, let us see an activity here.
Dear students, you observe this activity when two students are pushing the heavy box that is moving very easily.
If two students are pushing in opposite direction, you observe that the box which side, which direction moving. See which direction that box is moving. We can understand one student he is applying large force on that heavy box.
Dear students, this is the tug of war game. In this game, two teams are pulling in opposite direction. Which team pulling very strongly, that team winning finally.
Dear students, I hope you have seen a game of tug of war. I hope you have played the game of tug of war. Dear students, in this game, two teams pulling a rope in opposite direction. Dear student, both team members, when the playing tug of the war game here, both team members are trying to pull in opposite direction. One team is pulling the rope in right side and one team pulling the rope in the left direction. Dear students, sometimes the rope simply does not move, isn't it? Sometimes when one team member say are applying force largely, when they are pulling very strongly, then only that team winning finally. Dear students, what do these examples suggest about the nature of the forces? Dear student, in first activity, we observe this point when forces applied and an object in the same direction add to one another, that heavy box moving very easily. Okay, if when one student pushing the table, that is not moving very easily. When two students are pushing the table, that is very easily moving from one direction to another direction. Dear students, if the two forces acting in the opposite direction on an object, the net forces acting on it. Dear students, it is the differences between two forces. Dear students, in tug of war game, when two teams pulling equally, the rope does not move in any direction. Dear students, we learn by this activity, a force could be larger or smaller than the other. The strength of the force is usually expressed by in magnitude. Dear students, next point, net forces. Net forces mean it is the vector sum of the forces acting on a particular body. Dear student, next point, two or more forces acting on an object, that is cancel each other effect, that is we can say to be balanced forces. Dear students, balanced forces mean two or more forces acting on an object, that is cancel each other effect, that is we can say to be balanced forces. Dear students, the forces are equal and the net forces is always zero. Dear students, next point. Dear student, if two or more forces acting on an object, that is not cancel each other effect, that is we can say unbalanced forces. Dear student, the forces are not equal and the net forces also not zero. Dear students, in today's class we discussed force, a push or a pull, and second point we discussed force are due to an interaction between two objects and exploring forces. Dear students, remaining points I am going to discuss in tomorrow class. Thank you.